Hello, Joshua here, full stack engineer in the Incubation engineering department. I'm working on APM, application performance monitoring, management, and observability for the Gitlab DevOps platform. This is my weekly update video. You can see here my demo or update issue, if you like, for today, covering the last week. So one of the main things I did in the last week was fix a fairly significant bug in the existing implementation with the handling of Datadog tag sets. So this is where you have higher cardinality data going into the database. We weren't grouping correctly on that data when it was incoming, which was meaning that when I was doing some investigation into higher cardinality data that I would expect, say, from Kubernetes, a good example being pod data, specifically all the sort of tags you get around that, I was seeing very, very slow updates from that data source compared to a standard metric like just a host CPU. One solution could have been that maybe this was sending that high cardinality data at a much lower rate in the agent. But I actually found it was an issue whereby I wasn't deduplicating or grouping the data correctly based on the entire unique tag set coming through in the series data from Datadog. Now, this means that we were losing chunks of data, and it was sort of an ordering or race condition where certain bits of data would be dropped, whereas other bits would be kept. And I fixed that. I've added more documentation around it now. So I'll show you some of the docs that I've added into our project here. So there's a better Datadog agent docs here. I thought I better put these in while I was doing that work. So there's documentation around the series endpoint that I'm talking about here. So this is an example post. And information about how we handle metrics and custom metrics, information around the validation rules that we expect based on the Datadog API. And I've got tests around all these now to make it a bit more robust. And more specifically, how we convert that series format into our measurement format that we use in the ClickHouse database. And I've got some information here about how those more converted in more detail, so it's easier to refresh on that information. And the key bit here being that it's grouped on this unique set here of the host timestamp measurement and the unique tag set, which is the bit that I was missing before. That sort of transfers into this Golang structure here. So I can show you a running database now, just to give an example of the sort of cardinality of data we've got in there. So if I have a look, this is running on my machine at the moment, and you can see I've done a count of metrics there, individual metric measurements. That's a measurement name, and it has a tag set, and it has a set of field values associated with that measurement. You see there's quite a lot there, quite a significant amount. That's because it generates a lot of data. If we look at the distinct measurements in metrics, these are all the different unique top level measurements that we're getting, and there's a lot of stuff. So a lot of Kubernetes metrics there, system metrics like CPU, memory, and things like that. So for each one of these, then you're getting an insert with a unique tag set. You're getting individual fields. Some of them just have one field, some have multiple fields associated. So just as a refresher, let me just, I'll show you, I'll just move my little box out of the way. So we can do select star from metrics where measurement equals system.cpu. And you can see the CPU metrics there. And as an example, this doesn't have any tags at all. These are the tags fields here, but it does have a lot of different fields. So in its own way, it's relatively high cardinality. Those are all the fields associated with one CPU record, and these are the array values that are stored with it. But as an example of a high cardinality tag set data source, let's look at what I'm going to do here is get Kubernetes CPU records, and I'm going to array zip the tag key and values together, just get one out of there. And what you can see here, this is just one record, this is the tag set for that record. You've got a lot of different fields associated with it. So you've got a container ID, container name, display name, Docker image, image name, image tag, container name, kube namespace, pod name, pod phase, short image. It's got a lot of fields, and there's a lot of different variations of this sort of thing. And I was seeing way less than I expected. So I managed to fix that issue. So if I actually take the limit off there, we get 2,700 odd rows there, which is more, what we would expect to have that data set. So that's good. So back to the other thing that we were doing. We were getting the Datadog endpoints and general sort of time series endpoints integrated with GitLab so that we could tie together an API key provided by an agent with a GitLab project and optionally an environment. And I showed you a bit of this work last week. We've made good progress with this. It's nearly functional. So just as a reminder, we've got some documentation here as part of this issue, talking about adding these environment variables as global tags in the case of Datadog, but this would work with other agents as well. And what we actually discovered while we're doing this, these don't end up on every request with Datadog. There's actually an initial intake request that ends up with these host tags specified. So we need to be able to strip those out of that request and then pair those up with the API token. And the last bit we need to do with that is pair that together with those access rights and store that in some sort of session storage as part of the solution. So I'm thinking of having a simple Redis cache in there for now. So this stuff can have a one-way hash on it, and we'll store that information based on the API key and the host name. So the uniqueness constraint would be that the whichever agent is running this for a particular API key and a host name, you would be limited in that combination to a specific GitLab project and environment. I don't think this is really an issue. If it is for an end user, what they can simply do is generate another API key if they think they've got host names that are going to clash, and that can mean that you can have the exact same host name but associated with a different project. And I think this makes sense because a lot of the time you're wanting to have unique host names within a particular project or cluster anyway, and it would make sense not to have duplicate host names because it would make the data much harder to explore. So I think that constraint is acceptable in this case. Excuse me. So I showed you before this example of the Gitlab API. I've updated this for the intake endpoint that we were talking about. And what we do and what we've got implemented as well is when we get a project back successfully to attach to a metric set, we just check that the permissions part of the response is set and that it has an access level equal to or above 30, which means that the API token is associated with a developer level account. And the assumption there is a developer level account in GitLab will be able to write metrics data to a project that it can access. And I think this is a fair assumption. I think that's the right level. I don't think it needs to be the maintainer level. It should be the developer level as a minimum. So that's good. That's implemented now. What was the next bit? The other part of that is for local development, we created a GitLab stub service, so we don't have to have a GitLab instance running or well-known keys configured in gitlab.com or whatever. For local dev, I've just created a stub for the endpoints we need. Again, I've documented this a bit better as well as part of the documentation. So the local stub endpoints you can see here, these are the ones we implemented, and these are the ones we need. So we need to get the project's ID, get a project by ID to work out what these permissions are, optionally get the environment so we can validate that environment variable. And then we use the version endpoint to do basic API key validation, and that's part of the standard GitLab API. So when the agent does a verification request for the token, we can just check against that endpoint as well. So that makes it nice and simple. I'm trying to think if there's anything else. I think that mostly covers what we've been up to. So I fully expect that we'll get this project level integration and validation working within the next week. I should be able to demo that this week. So that's everything from me for now. Thank you very much for watching.